Okay, here we're given two ratios. Tangent of alpha is 3 over 5 and sine beta is negative root 3 over 2. We're told what quadrants they're in, 3 and 4 respectively, and we're asked to find the exact value of sine alpha minus beta. Now we know what the formula is for sine alpha minus beta, and I'll just write it out here. Sine of alpha minus beta is sine alpha cosine beta minus sine beta cosine alpha. So essentially what we have to do, if we're not given these ratios here, is to find each of these four ratios and substitute in. Now we already know what sine beta is. It's given. It's simply negative root 3 over 2. But we have to use the other ratios, tangent and sine. I'll get rid of that in 1 second. So basically these two ratios, in order to find alpha and beta. So basically we know that this is in the third quadrant. Tangent of alpha is in the third quadrant. So we can draw a reference angle in quadrant 3. And as we know, so alpha is in here. Tangent is the opposite, which is 3, over adjacent, which is 5. You might say, well, that's a positive number, and it is, but you notice there's negative on the x-axis and negative on the y. So we need to find the hypotenuse we can call r. And we simply use the Pythagorean theorem. R squared is equal to negative 3 squared plus negative 5 squared. So r squared is equal to 9 plus 25, which is 34. R is equal to the square root of 34. Again, this distance is always positive, and this is the exact value, so you don't evaluate root 34. And from that we can find cosine, which we'll probably do now. Cosine of alpha is going to be the opposite side, the adjacent side, which is negative 5, over the hypotenuse, which is root 34. And we can also find sine alpha, which is the opposite side, which is negative 3 over the square root of 34. And those two values we can plug back into here, sine and cosine. So again, these are positive values. Now we're also told that sine of beta is negative root 3 over 2, and it's in quadrant 4. So we can draw a reference angle for this in the fourth quadrant, call this beta. And of course the sine is opposite, which is root 3, and the hypotenuse is 2. This would have to be a negative, because it's a negative on the x-axis going down. So we solve for x. And using the Pythagorean theorem, x squared plus negative root 3 squared equals to 2 squared. So x squared plus 3 is equal to 4. X squared is equal to 1, and for us, x is equal to plus 1. Again, it's plus 1 because it's on the positive axis. So we can find here, we know what sine is, we can find cosine of beta. And cosine of beta is the adjacent side, which is here, which is 1, over hypotenuse, which is 2. And now we can plug these values back into here. So, we were again asked to find sine of alpha minus beta. Now let's expand it again. Apologize for the writing. Sine alpha cosine beta minus sine beta cosine alpha. And we substitute in the values that were given. Now sine alpha we know is this number right here. So it's going to be negative 3 over the square root of 34. Put a brackets there. Cosine beta we just found up here is 1/2. Sine beta, if you recall, was given. So sine beta is negative root 3 over 2. So we substitute in here, so it's going to be negative root 3 over 2. Again, brackets. And cosine alpha we found earlier as well, which is this number right here. It's negative 5 over the square root of 34. And we simply simplify, combine terms if we can. So we're going to have negative 3 over 2 root 34. And we got 3 negatives here, so it's going to be minus, well, root 3 times negative 5 is going to be 5 root 3 over 2 root 34. To combine terms here, negative 3 minus 5 root 3 all over 2 root 34. Now you can rationalize here, you can take out a negative sign here, but this is the exact solution. And for us, this is fine. So once you get here, you've actually found sine of alpha minus beta. That's the exact value, and we are done.